note that the placement of the strings here, well, they are where they are primarily because of the order in which we inserted things. And then some things, like for example, GGG was kind of placed a few steps from where it was, but then like DEF, poor DEF, I mean, it has to go 1, 2, 3, 4, 5, 6 spots away from where it originally wanted. There's this situation where we don't have this equity amongst the strings here, that some strings are close, some strings are far from their home place. And this sort of situation is really undesirable. Now, there's a further problem here with open addressing with linear probing, is that suppose now that we start deleting items. And so suppose we deleted the item here XYZ. So if we're going to delete the item XYZ, actually the way that that would work is that we would hash first to index 0 because X has ASCII value 120, mod 10 is 0, but because of linear probing, and this is not XYZ, and because this is full with another value, we would necessarily have to go to the next spot. And so we see EEE. Okay, EE is not XYZ, but because XYZ could have been placed further down the array, we have to keep looking. And so then we'd have to look here, and then we see, okay, so XYZ is here, everything is good, we found it. And then at this point, what we would do is we could remove it. Now, however, suppose we want to try to do a lookup for the value of DEF. So for D, we know we would start here at index 0, and we see that, well, DEF is not there, but because we're using linear probing, we'd have to go to the next one because this is full, and we'd see, okay, EEE, this is also occupied, so we have to go to the next one, but we see that it's empty here. So generally speaking, if this was empty here, then we would just quit. It's like, so that particular string that we're looking for would have necessarily been put here because it's empty, but that's not really the case, because DEF we see is right over here, and the problem is because this place here is now vacated when we removed XYZ. And so in linear probing, generally what we need to do is have some sort of indicator to state that something was here before, that something previously existed in this spot, and so we may still need to look further down the line to find that string DEF, which is all the way down here. So the way that this is generally done is that some special marker is generally put there. It's often termed a tombstone, which is like a grave marker. That's an indicator that something used to be there, but it's no longer there. But we need to kind of mark this off so we know that if we encounter such a place, that when we do a search, we would necessarily have to continue on in our pursuit of a particular value. And we see that this situation gets even worse when we start deleting more values. So suppose we went ahead and deleted all of these other values, like so, and if, say, in this situation we wanted to search for DEF, we would necessarily have to start at the same spot as we did before and do this linear probe and have to traverse all of these tombstones here before we finally got to DEF. The problem with this is we have a hash table that only has 3 values in it, but this DEF, it's far away from where we'd like it to be. And in a sense, we have a hash table that behaves poorly, not because we have so many values in it, but because we've had a bunch of values in it previously, but now those spots are left vacated, but then we'd necessarily have to pass those places over when we are doing a linear probe on lookup. So it is the case that if, say, for example, we wanted to add GGG back into the mix here, so we like Gennady Golovkin, so then we would end up placing him at this position here at 3, like so, and that's perfectly fine. We can overwrite a tombstone like that. But still, in a sense, we're still getting poor performance because of these places here that had to have been marked off.